Hi guys, this is some of the visual videos to go along with the mathematics that we discussed. I'm going to do these individually so that it's shorter and you can go back to it in case you need it. So what we're going to start off with is the first one we talked about was mass. Mass milliampere seconds, not mass MASS. That refers to the quantity of matter in an object, meaning typically when we think of mass, double S, MASS, we think of weight, not that. This is the technical factor of milliampere seconds. In milliampere seconds, milliamperage, remember milliamperage is 1/1000th of an ampere, okay? And seconds refers to time, which is always given in seconds. Typically it's in milliseconds. So what does mass affect when we said that? It affects your exposure. It affects how much black there is on an image receptor, because when that photon makes it through the patient and strikes your IR, it actually makes an area of exposure on the IR, which gives you your black. Where there's no exposure gives you your white. So it's the differences between the black and the white that actually allows us to see an object, okay? Mass affects quantity only. Now what do I mean by that? It affects the quantity of electrons that are released from the heated filament during thermionic emission. So ultimately, it affects the number of photons that will be contained in the primary beam. So mass only affects quantity, nothing else, all right? And in order to calculate our mass, I'm going to get rid of this. Mass is a mathematical equation, and literally it's milliamperage times time equals your mass value. So it's MA times your time equals your mass. All right, now let's just start with something simple. If you had, let's say you had an MA of 100 and a time of 2 seconds, 100 times 2 literally would give you 200 mass. Okay, simple. If the variable falls on the end, 100 times 2, if that was what I gave you, and I said it gives you how much mass, then you simply multiply, and 100 times 2 would give you 200 mass. So let's keep the same formula, but move the variable. Let's say I wondered how much MA you would be at if you were set for 2 seconds and that gave you 200 mass. Now, how would you solve for that? The X ends up being over here, so X times 2. First thing you would do would be to divide by 2 on both sides. So when you get 2 divided by 2, that leaves you with 1x, and 2 into 200, or 200 divided by 2, gives you 100, and that variable would be 100 MA. Does that make sense? So no matter where the variable is, you're solving. So let's do one more and make the variable in the time factor. So this is 1. If your x was there, 2. And then in the third one, let's just say that you had 100 MA times X gave you 200 mass. All right, so 100 times X, to get rid of that, you would divide by 100 both sides. And that would leave you with X equals 2 seconds. Okay? So pretty easy, no matter where the X is, you're simply solving for that. And that is how you calculate your mass. Now, the only other thing that I wanted to show you with that is that sometimes they'll give you your time factor as either a decimal or they'll give it to you as a fraction. So if they were to give it to you as a fraction, like let's say they did 50 MA at a 40th of a second, and they want to know how much mass is that. A 40th a 40th of a second, literally you take 1 divided by 40, and that should give you 0.025 if I remember correctly. So 1 divided by 40, 0.025 is your decimal. So then you could go back in and do 50 times 0.025, which would give you 1.25 mass. Okay? So sometimes they'll either give it to you in decimal form or in fraction form. But if it's in fraction form, don't panic. All it literally means is you take that top number divided by the bottom number, and that will give you your decimal value. All right? All right, and then the only other thing they mentioned in there is that your mass is directly related to your exposure, meaning it's directly proportional. So if your mass increases, then your exposure increases. If your mass doubles, then your exposure doubles. Okay? No matter what you do to one, it has the exact same effect on the other because it has a directly proportional relationship. Mass and exposure have a directly proportional relationship. Right? So these are, this is one of the set of the technical factors that we set. We want to know the mass that we use on something. Typically it comes into play with how big is the part, how thick is the part, is there any pathology to the part, what's the denseness of it, is it more radiopaque, is it more radiolucent. That comes into play when we're talking about the penetrability as well, but how much we need to pass through it, absolutely those factors come into play. All right, and that is MA times time equals mass, and that's all there is to it. Thank you so much. Have a good day.